Here's the answer to number 16. You've got a lamp hanging from two cords. Luckily, they're at the exact same angle, and you need to find the tension. Drawing the force vectors on this thing, you've got the tension here, and in this case, we can actually identify them as the same tension. The same angle, so that's kind of nice. And the force of gravity down here is 110 newtons. Don't get confused, 100 newtons. Don't get confused in this case. They didn't give us the mass of the lamp. They actually gave us the weight, the force of gravity on it. What should we do in this case? We know the sum of these three vectors have to equal 0. We can break these two tension vectors into their horizontal and vertical components. Here's the horizontal, here's the vertical. And identical on this side as well. And again, yes, you could draw these up above as well. I always like drawing them below just so I don't run into anything. But either way works. The angle down here, as you can guess, is also 40 degrees, opposite interior angle on both sides here. And then finally, what do we know has to be true? Well, we know that the two horizontal components have to be equal to each other. This piece here has to equal this piece here, because we know the net force has to be 0. And then, what do we know has to be true? The sum of the verticals have to add up to 0. We've got 100 newtons acting downward here, and we've got two equal vectors acting upward here. They each must be 50 newtons. Because they're both 50 newtons, you could go ahead and calculate the horizontal, but what we're really interested in over in this case is the tensions. We know the opposite side from the 40 degrees, and we're looking for the hypotenuse. You should immediately think sine. So in this case, the sine of 40 degrees is going to equal the opposite side, which we know is 50 newtons, over the hypotenuse, which we don't know. It's our tension. Rearranging just slightly, if you take 50 divided by the sine of 40, you'll discover, if you use your calculator, that the tension in this case on both sides is, to 3 sig figs, 77.8 newtons. And that is the answer to the problem.